Hi, in this video we want to talk about the electromagnetic push that happens in what we call the motor effect. We need some basic bits and pieces to make up an electric motor. Firstly, we need some kind of circuit that's not shown here, but we've got positive terminal here, a negative terminal here, fed from some power supply. These little brushes touch on these two rings, which we call a commutator. They're connected to either side of a loop of wire, and the idea is that we've got positive here, so current flows in, up this side of the loop, back down the other side of the loop, and out again. Now, those of you who've been looking at Fleming's left-hand rule will realise that if we put this in a magnetic field, and we've got a current flowing up through a magnetic field here, then there'll be a push on this particular conductor, and there'll be a different push on this conductor, because if current is going up here and across, it's coming back down on this side. Now, between the north and south poles we have field, which is running that way. On this particular instance, on the right hand side here, we have current, which is heading that way. And if you do the left hand rule on that, then you'll find that this side will be pushed down. Now on the other side we have the field going the same way, but the current is the opposite. So we've got field going this way, current is coming back down on that side, and so that side will be pushed up, and so we'll get a rotation of this coil based on the field going from left to right and the current going up one side and back down the other. So we get a torque that rotates the coil. Now the smarter people amongst you will realise that once this thing rotates, so that this has been pulled down and this has been pulled up, it can't go any more than half a turn. And that's where this commutator comes in, because every half turn it swaps what side of the circuit it's connected to. So this terminal is currently connected to the plus, but half a turn will bring the other terminal over and connect it to the plus. And so the current reverses, and that allows the rotation of this coil to keep going. This is a little model I made to show you what happens. We've got magnetic field running across this zone. These two connectors represent the brushes. This little piece of foil represents the both sides of the commutator, and this big metal loop represents the coil. And I've used arrow convention here to show you that current is coming up on this side, so we can see the tip of the arrow, and current is going away from us on this side, so you can see the flights of the arrow. And what happens is that down here at the commutator, every half turn the metal parts swap which side they're connected to. At the minute this one is connected to the plus, but half a turn later the other one will come over and connect. And so what happens is that every half turn the current in these sides reverses. So I'll see if we can show you that in action. So you'll see these sides swapping every half turn. So the direction of current keeps changing. And in a moment it'll slow down and you'll be able to see it more clearly. And what's happening is that down here we get a little bit of swapping over of the connections to the commutator. You can see it in slow-mo here, that which side is connected to which terminal keeps changing, and that causes the current to reverse every half turn, and that keeps the whole thing going. So current's heading down, then it flips and heads up, and that keeps the rotation going. And that's how the basic DC motor works.